This represents a neutral atom in electrical balance. Earlier, we saw how an outside force can break an electron away from an atom and start an electron chain reaction, an electric current flow. One way to provide that outside force is by use of a magnet. It was proved with iron filings that a magnet has magnetic lines of force which connect its poles. For simplicity, let's consider the effect of this magnetic field on a single electrically neutral atom. Now, we move the magnet so that the magnetic field strikes the atom, supplying energy which forces an electron to leave its atom and become a free electron.
Thanks to magnets, we've been making the world run faster for hundreds of years. Magnets allow for a current of electricity to flow from place to place and opposed to static jumps in charge. Rotate a magnet around a generator, and you can provide electrical power for a planet. Of course, humans have thought of some pretty interesting ways of turning that generator. We started with water. Boiling water gives off enough steam to turn a turbine attached to a generator. It's clean, it's cheap, but using a static heat source is far from efficient. In need of something that burns quickly, the world settled on a solution 200 million years in the making. Now, I tried to get some real dinosaurs for the making of this movie, but it proved a lot harder than I thought it would be. So instead,
we'll be using the next best thing.
Coal and oil were both once living, and they're fossilized after a rapid burial,
as seen with the pancake.
Because of their biological makeup, coal and oil have tremendous potential energy. They ignite efficiently once inside boilers and cause water to vaporize incredibly quickly. One coal or oil plant can provide enough electricity for 1.5 million homes.
We use it because we can. In the real world, we make electricity by boiling water.
But what's so bad about the fossil fuels? Coal or oil plants use on the upwards of 21,000 tons of dinosaur every single day. That's a lot. The solution? Better living through nuclear chemistry. Uranium, or its man-made counterpart plutonium, can provide the same amount of electricity as fossil fuels through much hotter materials. With nuclear energy, 28 tons of uranium or plutonium are needed per year. That's 300,000 times more efficient than any fossil fuel. While nuclear technology may remind us of darker, more explodey uses, the technology is much safer than anyone really gives it credit for. Of course, nuclear energy is not risk-free and is far away from the energy utopia the 1950s predicted, but is a step forward from fossil fuels. Nuclear energy has been heating our planet for cheap and without mass pollution for several decades, but the best answer is literally right below your feet. 10,000 feet down, you can't really see much, but this is where we tap into Earth's magma and extract it for geothermal usage. Geothermal energy is also water-based, but uses renewable heat found absolutely everywhere on Earth. The conduction of our magma vaporizes water into steam. We can use this steam like any other service by sending it to a turbine. And just as predicted, after the turbine moves, that energy gets sent to an electromagnetic generator. Geothermal energy, unlike anything before, is renewable. It taps into our own reserves, and after the startup cost, it's free and pollutes nothing. It's honestly that simple. We will always need new ways to power our world, and this is the starting point for those ideas. Our future fuel is our collective intelligence, and it starts with every one of us.